the universe just got a whole lot more fascinating. Einstein's theories and the nature of hypothetical particles are being put to the test by groundbreaking black hole collisions, and the results are mind-boggling. The LIGO-Virgo-KAGRA Collaboration has announced two extraordinary events in the realm of gravitational wave astronomy. These events, detected in October and November 2024, are not just any ordinary occurrences, they are record breakers that could revolutionize our understanding of the cosmos. But first, a bit of context. In the decade since the initial detection of gravitational waves, scientists have been on a thrilling journey, observing hundreds of these waves resulting from the cataclysmic collisions of neutron stars and black holes. And now, these two new events are about to shake things up. GW241011, the first of the pair, occurred on October 11, 2024, and it was a real showstopper. Imagine two black holes, one a whopping 17 times the mass of our Sun and the other a mere 7 solar masses, colliding 700 million light-years away. But here's the kicker, the larger black hole was spinning at an astonishing 75% of the maximum speed theoretically possible. Talk about a cosmic whirlwind. And if that wasn't enough, GW241110, the second event, had black holes with similar masses, but this time, it's the spin direction that's intriguing. Typically, black holes spin in the same direction as their orbit, but this larger black hole was spinning in the opposite direction, a true rebel. This is the first time such behavior has been observed, and it's a big deal. The implications are profound. These events suggest that the larger black holes were themselves the result of previous mergers, making them second-generation black holes. This not only tells us about the history of these black holes but also about the dense environments in which these mergers occur. These events provide tantalizing evidence that these black holes were formed from previous black hole mergers, said Professor Stephen Fairhurst, emphasizing the significance of these observations. The precision of these measurements is so extraordinary that they allowed scientists to conduct particle physics and general relativity tests, opening up new avenues of exploration. In the realm of particle physics, the team investigated the potential role of ultralight bosons, hypothetical particles beyond the standard model, in explaining dark matter. And they made significant progress, ruling out a wide range of possible masses for these particles. As for general relativity, the team searched for discrepancies between Einstein's theory and observations, but found a remarkable agreement. However, the quest for what lies beyond Einstein's theory continues, and more observations of these events could hold the key. We're more sensitive than ever to any new physics that might lie beyond Einstein's theory, said co-author Carl-Johan Heister, highlighting the potential for further discoveries. This research, published in the astrophysical journal Letters, is a testament to the power of international collaboration in unraveling the universe's deepest secrets. But wait, there's more to the story. These findings raise intriguing questions about the nature of black hole formation and the environments in which they thrive. Are these black holes truly the result of multiple mergers? And what does this tell us about the cosmic neighborhoods they inhabit? The answers may lie in further observations and the ongoing collaboration between scientists worldwide. What do you think about these groundbreaking discoveries? Do they challenge your understanding of the universe, or do they confirm what you've always suspected? The universe is full of surprises, and the more we learn, the more questions we seem to uncover. Share your thoughts and let's continue exploring the cosmos together.